we should also look at the derivative of the natural logarithm. As we've seen before, and if you haven't, check back the lecture notes, the derivative of ln x is given by 1 over x. The demonstration is a little bit more advanced, but I would encourage you to really check it out and try it yourself. But what about if you have a function which is ln kx? Can we differentiate this? In principle, from first principles, we only looked at ln of x, not ln of kx. But this is another great opportunity to show you how you can split up functions in order to be able to use the rules that you already know. In this case, if you remember the properties of logarithms, you can write that ln kx is the same as ln k plus ln x. And therefore, you can write this in a way that we can use differentiation rules, which is essentially the sum rule. This means that the derivative of ln kx is the derivative of ln k, that is 0, plus, because there is no dependence on x, 1 over x. Which means that even if you have a constant here, the derivative is still 1 over x. What about if we have a logarithm with another base, say log base 10 of x? How can we differentiate this? First of all, let's get rid of everything here so we can have some space. Our goal is to be able to differentiate something like this. We want to calculate this, but this is not necessarily straightforward. We know how to differentiate ln of x, and we know that this is 1 over x, but not necessarily log 10 of x. Therefore, what we need to do is sort of manipulate this and transform it into ln of x. One way that we can do this is by writing that y, in this case, this is the function, because it is equal to log 10 of x. This means that we can reverse the functions and write x equals 10 to the power of y. Once we get to this stage, we can also take the natural logarithms on both sides. ln x, ln 10 to the power of y. Because of the properties of logarithms, if we drop the y there, we can rewrite this as ln x equals y ln 10. And also, we can take this to the other side and write that y equals ln x over ln 10. This means that we now have an expression that we can very easily differentiate, and therefore we can think of this as using the constant rule, thinking as 1 over ln 10 is the constant. Therefore, we get 1 over ln 10 times the derivative of ln x, and this gives us finally 1 over ln 10 times x. You could do the same exercise of, instead of using base 10, you can have some base a generally, and you can arrive at the fact that if you differentiate some log a of x, you get 1 over ln a times x. And again, you can memorize this if you have a lot of space in your mind, or you can always just know the basics, rearrange the expression like this until you can get it to a format where you can differentiate it directly.